Problem number 78. We are asked to find the derivative of the function y equals the inverse tangent of the natural log of 4x. So we want to use the inverse tangent derivative formula right down here, which is basically u prime over 1 plus u squared. And let's see what we have over here. So the u in this case, of course, would be the ln of 4x. So the derivative of natural log of 4x would be the derivative of 4x, 4, which is 4, over the 4x. It's du over u. And then the bottom is just 1 plus the natural log of 4x all squared. And 4 divided by 4x is the same thing as 1 over x. So, which, would not be incorrect to leave it as 1 over x on top. But to make it correctly match this answer, the 1 over x on top, the x drops down to the bottom, and then is multiplied by everything on the bottom, which has it match then answer B up here. So, all right, that's really all there is to that one. Number 79 is also a derivative of an inverse trig function. It's the derivative of inverse sine of e to the 4t. So we're going to use this formula for the derivative of arc sine of u, which would be u prime over the square root of 1 minus u squared. So it's going to be the derivative of e to the 4t over 1 minus e to the 4t squared. So the derivative of e to the u is always just e to the u du. So the derivative of 4t would be 4. So it's 4e to the 4t. And then e to the 4t squared, you just multiply the exponents. You don't square the exponent, you multiply the exponent. So 4t times 2 will make that be 8t. Problem number 80 is a derivative that's going to fall into the form of arc sine. And it's going to be based on this formula, the integral of du over the square root of a squared minus u squared equals sine inverse or arc sine. Obviously, those are always interchangeable, of u over a plus c. So let's identify everything we have here. U would be 3x. So that makes du equal 3dx. A squared would be 49, which means that a would equal 7. Now, there's on the u du, there's a couple ways you can look at this. A lot of times I normally pull the constant outside from the beginning, the 3, and then I would have divided both sides by 3 and then said dx equals 1/3 du, and that would have been fine. But you would have had a 3 on the outside, and then you would have had a 1/3 on the outside. They would have canceled each other. But you see what I did here, though, is I looked at the derivative of this being 3dx, and I saw that it was going to be a perfect match right there for the top. So since it was a perfect match, there was no need to pull that number out and then divide both sides. I mean, you still could have done that. Like I said, you would have had a 3 on the outside and a 1/3 multiplied together, and they just would have canceled. So it would have been the same thing. So you didn't have to catch that little thing I showed you right here. That, that's all right if you went ahead and did it the more traditional way. So that just leaves du on top, and you have the square root of 49 minus u squared. So that gives me inverse sine, or like I said, arc sine, whatever format is used on the exam. They're the same thing. And then u is 3x divided by 7, and of course your plus c. And there we have it for that one. It's all about getting the u du straightened out. This one, number 81, is a little trickier. Now, I'll talk about where the 9's come from. Where the 9's coming from is because that we have 81x squared here. So if that's 81, so you see the formula, it's going to be the inverse secant formula. And you see that that's u squared. So if 81 x squared is u squared, that means u is a 9x. Now notice this formula has this u on the outside. And we just have x. So we have to have a 9 right there next to that x to match this formula for the u. So, and then of course whatever you do to the bottom, you must also do to the top. So I just basically multiplying by 9 over 9, which is just 1. But this 9 on the bottom goes away because it combines with the x and becomes u. It goes away. Now the top one, similar to the last problem, I could have pulled the top 9 to the outside if I wanted to, but not the bottom 9. The bottom 9 stays with it because it's u. But I noticed again that if u is 9x, the du is exactly 9dx, so it fits perfectly. So that gives me then the du on top, and then we have the u on the bottom. Like I said, if you were to pull it out, you would end up with 9 times 1 over 9. Anyway, I'm not talking about the 9 on the bottom. I'm talking about the 9 that you would have gotten by dividing both sides right here. So it's du over u times square root of u squared minus 6. That makes a the square root of 6. So 1 over the square root of 6 times inverse secant of the absolute value of 9x over a, which is square root of 6. Now what I have here is correct. I showed the part for this is just all rationalizing denominators at this point to make it match that answer. I didn't show it here in writing, but on the outside, 1 over the square root of 6. If you multiply top and bottom by both by the square root of 6, that'll give you the square root of 6 over 6 right here. And then I showed here in green how this inside part turns into this part right here. If you multiply top and bottom by the square root of 6, you'll get 9 over 6 with a square root of 6 left over. 9 over 6 just reduces to 3/2. So 3/2 square root of 6. That's what makes it equals this. You know, if this was an exam that was being handwritten or something like that, I mean, I would not have expected all the rationalization of the denominators. But, you know, some authors' books will expect that. So, and it's good to know how to do it. But yes, so that my answer is correct. It's just I'm just showing you how to convert it to what the answer choice that we need to make is. So, all right, let's come down here to number 82. This one's a pretty straightforward one. The u is real easy on this one. This is going to follow the format here. It's going to be an arctan integral. It's du over a squared plus u squared. And this one's easy to negotiate because u is just x. So du is dx. A squared is 25. A would be 5. So we basically just have dx over 25 plus x squared, which I guess I left a step here. I could have written this as, I'll just say it, but I could have put du over 25 plus u squared. But it's still correct. I just didn't write that. Should have maybe written that step in there. Well, this one's real straightforward. So you get 1 over 5 here, 1 over a, inverse tan of u over a, which is x over 5, and then plus c. All right, that concludes problem 82.